Today's lecture is not theory. We're just going to mostly look at the logistics of setting up a project. And I already wrote down fairly extensive instructions on, let me get there, on how to set up a project. And I'm just going to quickly go through this for people who don't read and prefer to hear what needs to be done. So setting up a formalization project. There are a scary amount of steps here, but once you get used to it, it's really not that much about, because first of all, you don't have to keep installing new software every time. And eventually you get used to Git, so you don't think about Git anymore. And so then you're just left with Lean and Blueprint. Okay, so we are already doing this online, and please talk to me. Is there anybody here who doesn't know what to do for their project? Then I'm not. Okay, so let's see. If I remember what everybody does. There we have, what does he have? You're gonna have the Blossom thing, okay? Remind me, Steiner systems, okay? Relative monads, are elementary topos okay with you? Yeah. Okay. Localic stone duality, okay? Which one? Polyas theory, yes, okay. I don't know that one very well. I don't have a good feel for what's going to happen. I had a look, but it didn't seem, it seemed okay, so yeah. Matej, what are you doing? Oh, Kripke frames, yeah, yes, okay. You might want to also talk to Luna at some point, because she's doing triposes, and that sounds like it generalizes everything in logic. Job? The what? Ah, yes. So let's finalize that today. I think, but I think it was okay, right? From what? Yeah. Yes. Okay, so let's talk. And you were doing, remind me. Ah, yes, you're the partners in crime. Okay, we need to talk. Okay. Anyhow, so I'm assuming here for these instructions that you already have Lean and that you already know what Git is. If at this point in the course you don't know what Lean is, talk to me. And if at this point in the course you don't know what Git is, well, talk to me. So you also need Python. And if you're on Mac OS, I think your life will be a lot easier if you have the Homebrew package manager. So of the things that you already should have installed is Lean, of course, and in particular Lake. And you need to install the thing called Lean Blueprint, because I think it's a good idea that we all try to use it. It's a nice tool. So Lean Blueprint is something that allows you to write your plan of attack, your formalization in LaTeX, and then it will show progress. I'll show you what it looks like. But Lean Blueprint needs GraphViz, which is a graph visualization library, because it displays dependencies in your formalization in a graph. So then, first of all, you need PyGraphViz, because Blueprint is written in Python, but in order to get that one, you need GraphViz. So I'm not gonna spend a long time working on this. If you face problems here at the beginning, you should probably just say so on Discord and say, hey, something's not working. So that's the best way to debug, is to bug somebody who already knows how to do it. So then we install Lean Blueprint, which is a Python package. And I initially had an old version, like 0.09, which didn't do things that I think should be done. So make sure that you have a fairly new version. So for me, it's 0.15 is new enough. In any case, you will know that it's new enough if it generates top level index page for you. You'll see. Okay, so then the order of things goes as follows. First, you create a Lean project. And for that, you use the Lake utility, which maybe we didn't use so far because we're just using Lean. Oh, yes, maybe Lake. No, we used Lake probably to set up projects, like if you downloaded something. Anyhow, Lake, yes? Yeah, yes, please, yes. Lake is a sort of a build utility for Lean, which knows how to create a project, gives you a standard layout and so on. So I would suggest that this first time around, we don't muck about and just take the default settings everywhere. And the default settings are actually reasonable, so it should be okay. So you create a new object, which is going to create a new folder. This is the name of the folder. And then there are various ways of creating an object. So you can where are they? Really? What's the difference? Lake new help. There we go. It's the one that I want. So you can create an executable, which is not what we're doing. You can create a library and an executable. You can create just a library, and you can create a library which depends on mathlib. So this is the one we want, because we're all going to depend on mathlib. And then there are two ways to set up the configuration files, either by having a Lean file that configures things, which is this one, Lakefile Lean, or there's another format called TOML, and I suggest we just use Lean. Everybody use Lean, just so I don't have to double my brain when you talk to me and try to figure out which one you are. Just take Lean. And then once you go in, you want to do Lake update. This is going to update your Lean, and it's going to download lots of stuff. It's really download happy, this stuff. It's a bit like the node thing. It really likes to download lots of stuff. So, whatever. Yeah, just 4.8 gigs per project. But because it's mathlib is pretty big. And to avoid compiling mathlib, which is a non-trivial task, it takes a while. You can they've created something where you can just download a cached version of the compiled mathlib, and this is what this thing does. Sometimes people have problems here with this thing, and I think the general rule is that if the exec cache doesn't work and mathlib really wants to compile, then you replace this get with a get exclamation point. And that just means download the cache even if you think it's wrong, and even if you think it's going to break something, just download the cache, and then you hope it doesn't break anything. Okay, so the next thing to do is we actually open this stuff, and you want to go to the Lakefile Lean here. And in particular, let me try to get some space here. I keep for this one. I really want you to put this in, okay? Because it's going to save you lots of headaches. This I discussed before. Without it, if you mention a variable in a definition as a parameter somewhere, and you don't say that you really want it, it's not going to say it's a typo. Like if you have a typo in the variable name, it's just going to say, oh, you probably want a new variable, and it'll just create it. And so I think that is a bad idea. When you put this in, there are two possible traps. One is you forget this comma here, because it's not there when you first open the Lean file. And the other one is that these are not parentheses. They're the usual triangular things. Oh, maybe there's a third one, which is this is not an apostrophe. Anyhow, you should be able to... Ooh, what? Oh, I deleted the apostrophe. There we go. Anyhow, you should be able to... Where is my... you should be able to just copy this stuff here. And then you Lake build to see whether it works. And if it works, it should not take a long time. Well, this one has just been built, so I don't want to do that. Okay, so first you create the lake file. And by the way, when you create the lake file, it will already create a Git file. It will already produce a Git for you. It'll actually start a Git repository. It'll create this folder. So the next thing is to put this on GitHub. But now, because we already have a Git, we know which version of GitHub project we want. We want to create an empty Git project on GitHub, and then add to this guy, say where the remote repository is. So you create a new GitHub project, which is, I'm not going to do this now. I considered doing on video like another copy of my project, but I realized that that would just be a video of me trying to discover my own mistakes. The file that I wrote with instructions, this one, I did not do this in such a linear fashion, by the way, in case you have any doubts. Right? I made lots of mistakes, and I hope I correctly merged all the branches that I tried of what I tried. Okay, so where were we? Yes, so you go on GitHub, you press, here is a new button somewhere, new, you press the repository. Okay, so here, repository name, please, reasonable repository names, not project, okay? And I don't think you have to mention lean or formalization, just something. I can live with camel case, like if you really want to write stone duality with capital S and capital D and no dashes in between, that's fine. But look, you see, they suggest this kind of thing. The description should be just a one-liner, make it public, do not add a readme, do not add a git ignore, and do not choose a license, because any one of those will put files in your Git repository and you're going to have commits, and then you're going to have to learn how to force commit stuff and just generally suffer through Git. So don't do that right now. Okay, and then there's some instructions on how to add a new origin. Anything else here? Yes. Okay. So whenever the instructions say git add all, you should be kind of careful about that, because that can add files to your repository that shouldn't be there. I wrote this for simplicity because if you follow the instructions, at this point in the instructions, you should be adding all the files that are not added yet. But if you deviate it from the instructions, you might have some extra files somewhere. So be careful about what git add -- all adds. If it adds a gazillion files, something went wrong. Don't commit. Okay, don't commit. Come to Discord and say, help, I added 1,000 files to the Git repository. So for instance, for me, it was just these files here. Okay, then you push, and once you push, then you should start seeing something like this in your but still without the README file, right? But you should see the files here, but you're not going to have the README file. So, I keep doing the wrong thing. Okay, so where were we? Yes, so that should get you an empty lake file, an empty lake project that there's nothing in it. So the next thing that we do is we create a blueprint. So to create a blueprint, there are two steps. So what the blueprint will do is the following. You're going to write a LaTeX file, and then the Lean blueprint utility will generate HTML and it'll generate PDF. And you can look at the PDF and you can look at the HTML on your local folder, but it will also publish them online on GitHub, which is the cool stuff. If we have anybody who is apprehensive about having all this stuff published publicly, you don't have to do it, but I have two comments. One is you're part of the math community, it's okay. And if you're like worried about, oh, what will people think about what I do? They will probably think it's very cool, yes. And if you really don't want that, then don't do it. So Activate GitHub pages is the first thing. This is when you have a GitHub project, you can also for free get associated web pages for the GitHub project. And so many people, for instance, have their homepage done that way. So there will be a web page that is associated with your project, and you need to activate that first. So you just go to settings. So where is settings? Settings is up here. Here you go to settings, and then you go to pages, and then you activate the GitHub pages. And there are several ways to do it, depending on how you're going to manage them. And so the instructions say that you should do GitHub Actions. That's not the only option. I'm a little bit afraid of choosing anything else, but it could be deploy from a branch. Deploy from a branch would mean that you're going to put your HTML files into one of your branches, and then it should just get copied over, and that will be your website. GitHub Actions is something else. GitHub Actions is a mechanism for running various kinds of scripts every time you push to GitHub, or in general, if you say that it needs to run. It's down here under Actions somewhere. Oh, here, up here under Actions. And these actions essentially can do anything, more or less. And what happens is that when you run an action, GitHub creates a little virtual Linux for you, and then in that Linux you do whatever you want. So for instance, in this case, what we're going to do is where every time you do this, so this sounds a bit scary and weird, but it works really well. So you get an empty Linux without anything. So your action will first install LaTeX, it'll install Lean, Python, everything. It'll install all software dependencies that you need to run your project. Then it'll download MATLib, all of it. Then it'll create your project, and then it'll build the project. It'll build the web pages. Then it will package up the web pages in a zip file, and then it'll actually deploy those onto an HTML page every time. So every time a little Linux is born and it dies when you run one of these GitHub actions. It seems like I think the first time you hear about it, it seems like, wow, really? So here you can see the actions that were run for my project, and the green ones are the ones that succeeded, and the red ones are the ones that had errors in them. And you can go and you can look what failed. So you go here into the action. So I clicked here on the actions, and so first of all, it takes for my project, it takes about 8 minutes to complete. So this is a Linux which only saw the light of day for 8 minutes, and then it died. Of course, GitHub is trying to be very smart about this. So it's trying to cache things, and it'll discover that it doesn't have to like reinstall everything. It's trying to be smart about what to do, but you really don't have to worry about this part. I'm just explaining the philosophy of it. Okay, so you see, set up a job. These are the various steps. Check out the project, install Lean, get MATLib cache, build the project, everything, and then it died. And the thing that died was Blueprint. And Blueprint died because it was complaining that in my LaTeX file I mentioned things from Lean that weren't actually there. So it said, okay, I can't build the dependency graphs because your blueprint is messed up. You can run these actions on your command line to check first. Like you can do the equivalent in your folder first before you push, if you're afraid of creating little Linuxes that are destined to fail, and you think that that's not fair. Okay. I'll run you through this. I'm just explaining what GitHub actions are. So then you go into your folder and you create a new Lean blueprint. And this is going to ask you a bunch of questions. And I'm brave enough. Am I brave enough to show you how this works? I think I need these two. I will remove the folders that Blueprint creates. So it will create some folders. It will also create a GitHub action, but when it says, so here's a GitHub action. This is what Blueprint creates. These are all the instructions on how to build things. I'll tell it not to do that. Okay, so I say Lean Blueprint. No. Oh, excellent. I don't have Lean Blueprint. Lean. Pip install. Let me try my luck. Lean Blueprint. This is the part I didn't want to do because it's going to lead to random debugging. Yes, there we go. This is real life now. This is what's going to happen to you. Fail to build installable wheels, okay? Fail to build wheels for PyGraphWiz. Oh yes, that's an error that I had to deal with. So PyGraphWiz is failing. PyGraphWiz. It's failing because it doesn't know where to compile things from. I'm not going to do this right now. It's you have to tell it where the library is. You can just copy paste it from the. Do you know where to go? In your notes, the official installation instructions for PyGraphWiz have them. Wait. Let me just say first, do I have this? That was not very useful. I should have said info. I want to see whether this is something that I already have. Actually installing it would be even faster because it'll tell us it's not installed. Okay. So first I need to install this. I thought I did this on this computer. Apparently I never ran Blueprint on this computer. That's because whenever I can, I prefer to work with a reasonably sized monitor. And this one is not reasonably sized. Let's hope it's not going to update 140 things. Maybe it is. It's really suspicious that it wants things like SQLite. Okay, how about we don't do this right now? Okay, so you run through your Lean Blueprint and then you build it, and you're going to get the way you know that something nice is happening is that I'll move this stuff from backup back to where it's supposed to be. You're going to see here blueprint folder, and you're going to see homepage. You also want to see the homepage files. But these are the two folders that it'll create, and then it'll put in some defaults. If we look at the blueprint, so this is going to look like something that's done with LaTeX. It is LaTeX, but in the background, Blueprint uses Plastek. I think that's what it's called, which is a Python implementation of LaTeX. And so that's how it generates HTML. So welcome to the world of software, right? There's lots and lots of stuff going on here. What you do is you put the content of your blueprint in here into content.tech, and then you can also have macros, and essentially then you can build this. But the real way you build it is you run on your command line. You run lean blueprint all. That'll create the PDF, the web pages, and it'll check that all your declarations are correct. And the first time only when you do this, you do git add all. I think it's safe. It will only add files that it's supposed to add. So maybe it's worth explaining which things you should not be adding to your Git repository. As a rule, you should never add to your Git repository any files that are generated by some utility or compiled files or PDF files. Do not add those. And the Git wants the source code. It doesn't want the generated files. Except that here, Lean Blueprint is kind of a meta utility which generated some files, which are source files. So you want to add those. And with a little bit of luck, you're going to get your Lean Blueprint. And let's have a look at that. It takes about 10 minutes, as I said, about 10 minutes for your actions to complete. You can watch your actions going. You click on actions and you'll see it running. You can click on it and you'll see live what it's doing. It's interesting the first and the second time, and it's not interesting the 10th time you look at it. And then you should have your homepage. And there are also instructions saying, please add a README file in the license, and they explain how to do that, and I'm not going to be super precise about that. So do add a README file, because when you add a README file, then you actually get this stuff here written. So let's look at the blueprint and the documentation. Oh, two things will happen. Not only the blueprint, also the documentation for your project will be generated. So the documentation looks exactly like the MATLib documentation. It's the same utility that does this. It's a Lean library. When you create your Lean blueprint, it'll ask you whether you also want to generate documentation. You say yes. Anything that Lean blueprint suggests, you say yes. And then you have lots of stuff here, all the dependencies and so on, but the one that you care about is partial combinatory algebras. And then, hey, you get like real documentation. So you get that, and you have search and you have everything. Let me show you what else is there. Then you can have the blueprint itself. Before we go to the blueprint, there is a project web page that gets generated. This is the stuff that is in homepage. If you open homepage, you will see this is your website. It's using Jekyll. Jekyll is another utility that creates static websites, so websites with fixed homepages, and it will automatically, if you have a file in the markdown format, it'll automatically convert it to HTML. So let's not open this with Microsoft Excel. How about this one? So it looks like this, and then you can write whatever you want here. So apparently I failed to pull here. So this is the actual file. I have an outdated repository. Let's not have an outdated repository. This, I don't want you to do this. Go away, discard. And then I want to sync. Where is sync? Sync. Apparently I just failed to use this laptop often enough. Anyhow, this is the same as the README, and then it will insert links to your blueprint. So you can have the PDF, which is now just a PDF, which you can completely format the way you want it. It suggests the report. It suggests report as your LaTeX document class. I changed it to article because I'm not writing 100-page report, and reports has chapters and then it looks humongous. So I just switched to article. It works. And then that's the plan. You see, it's not finished. My plan is not finished. I did not try to write down the precise plan because it's a fairly small project. I am kind of confident that I can first write down a rough outline. The blueprint at first was kind of a little bit rough. I just knew I wanted to do the basic definitions. Combinatory completeness is something that is a theorem that I really want. And then I knew I wanted to have some more programming with PCA, with the combinators, and I wanted to have some examples. That's my project. So the actual layout should be there, but I didn't know what to write under 3 and 4 because I knew ahead of time that there's going to be some fiddling with the basic definitions, and there was. And it took me a couple of iterations to figure out the best way to do the basic definitions, which is not unusual. And once you're fairly certain that you have the nice way of doing them, then you go on. How will you know you got the wrong basic definitions and basic setup? If it's a pain to do everything, okay? If it's a pain to just work on like even the simplest stuff, then there's probably a better way. So then you should go back and think and ask somebody, ask me, ask on Discord, like, I'm doing it this way, it seems wrong, is there a better way? Okay, so that's the PDF file, but there is also, where was I? There is also the blueprint as an HTML file. And now this one has check marks. I'll show you how you get those. It has checks. This means this is the stuff that was already formalized when you have as a check mark, but I hope not everything. Yeah, so the program, these guys are without check marks. And these guys are with check marks. That means done. And then when I click on here, I can see a couple of things. I can, okay, so this is just the link. I think this is just the link. I can see the Lean code. If I click on Lean, it says this is defined, this proposition is in expr defined appster. And if I click, it'll take me there to the documentation, expr appster. It's here, and I can look at the source code as well. So everything is super nicely linked. It's amazing that the idea of the World Wide Web works. Okay, you can have that. What else is here? So this takes me to Lean. Then this guy here takes me, there's one that takes me to, oh, this one takes me, how about bigger fonts? This one takes me to the dependency graph. So here's the dependency graph. It says what is needed. It says it uses definition 2.1 and it uses definition 2.3, and I can click and I'll get to that definition. Here's definition 2.3.
How does it know how deep to go? Does it only
every link, everything is done manually. It's because I wrote it. Even the fact that the formalization is done is something I tagged in my blueprint. So the blueprint is completely manual. The only thing that Lean blueprint will do is it'll check whether you misspelled your Lean identifiers. That's the only thing it knows how to do. Okay. Yeah. This is, let's see, this is the link on this page. What is this? Go to 008 on this page. I don't know, more links, confusing. Oh, the proof, there you go. Some proof, okay. The proofs can also be checked and not checked, and apparently I forgot to check this one. I want to show you, okay, I can do this. Let's just click on everything. I can go to the proof. I can go to the definition, which will go locally in this file. These are the dependencies, and I can go to Lean. It'll go to the documentation. Okay, which is kind of useful. We can have a look at the real blueprints later to see what they look like, because this is a strange blueprint. Okay. Then there's the dependency graph. This is the coolest thing. Okay, you can no, there we go. You can move it around. It doesn't want to zoom. You can zoom it. Why doesn't it want to zoom? Well, no, there's a way to zoom. There we go. You can zoom. Of course, this is way cooler when your graph is bigger. So what do you see here is you see the dependencies, and the more green it is, the more finished your project is. So a part of it is finished for me. I proved combinatorial completeness of partial combinatorial algebras, which was surprisingly easy, by the way. I thought it would take longer. And the next thing I have is just write down some combinators and they're defining equations. And then I'll have examples, and I expect examples to be the most complicated, because the canonical example of a partial combinatorial algebra is the one based on partial recursive functions or Turing machines, and neither sounds like fun to formalize, because I need to prove the UTM theorem, which says that there is a universal Turing machine. And maybe I'm thinking of whether I really want to formalize the universal Turing machine. We'll see. Okay. Where was I? Yes. That's the graph. Let's have a look at some real ones. Where is the Lean blueprint? This looks like the main one, but okay. So this is a real one. Do you know what the sphere inversion is? Sphere inversion idea. Which one is the shortest? This one, I think. Watch on YouTube. Now we're gonna get some ads. Yes, I reject all. Maybe no ads. They know that it's pointless. Okay, so here, what is a sphere inversion? So you start with a sphere, okay? And this sphere is red on the outside and it's blue on the inside. And you want to turn it inside out. It's very, and it can cross itself. Okay, so if it can cross itself, it's very easy to turn it inside down, out. You just push from one side, you just keep pushing from one side to the other side, so that like from this, if I keep pushing like that, then the blue stuff will come out. And if I keep pushing enough, it'll come out and then it'll be blue on the outside. But the question is, can I do this in a smooth way? Because if I just push, there will be a crease in the middle, and that crease will not be smooth. And you might think, well, I'll just round it out, around it a little bit. And the answer is no, you're not going to do it in such a naive way. But there is a non-naive way of doing this, which is cool. Where are we? Theater mode. Apparently, I do not deserve to look at this. Yeah, let's refresh. Maybe we have to. Oh, no, no, no. I know what it is. It's playing. Yeah, but I think it's fighting the ad blocker. This works better with Firefox. The Safari ad, YouTube is really at war with the Safari ad blockers. I think we do want to watch a little cartoon, right? No, no YouTube for us today. Let's leave it here and see if it comes to its senses. But this is like now an actual blueprint that people also styled, because mine doesn't have a reasonable style. I don't care. And you see, that's their blueprint. And they actually comment on things. So this is not a mathematical paper. This is really a plan of attack on how to do something. So it's worthwhile commenting on the things you discovered. For instance, I discovered that the standard definition of the partial combinatorial algebra is not the one I want to use. I want to use a different one. And then this was after trying to use the standard one for a while and going mad with trying to do the monadic style programming with PCAs. And I said, no, I'm not doing this anymore. And then I switched to something much more simple-minded, and it worked. And so now I wonder, why doesn't everybody use that as the standard definition? And that's certainly something I want to comment on in my blueprint, because this is the kind of information that is helpful for anybody who's going to look at my formalization, and they will immediately see that my definition of a PCA is non-standard. I should explain why. So that's the real stuff. Should we look at their dependency graph? So this was done by Flores. Who was this? Van Dorn and somebody else. It escapes me who this. What, they did not sign their names? Okay, so I think this is about 2 years worth of a project, because the math is quite hard. There's lots of homotopy theory and things, and apparently I really am not going to see.
It works on my machine, so if you want to show it, you can plug it
I don't
into this
know.
computer.
I don't know what the hell is going on. Okay.
USB-C adapter.
Let's see. I am on FMF, but okay. Here it's worthwhile zooming in, and it's done, as you can see. Okay. And it looks, I mean, looks now exactly like the stuff that we had. So you can look at other people's blueprints. If you find the Lean blueprint GitHub repository, it lists them. Let's look at one that isn't supposed to be finished. I think Fermat's last theorem is not supposed to be finished. Okay. This is a 5-year project, I think, by Kevin Buzzard. So he's going to do this for 5 years. Hooray. Where is the dependency graph? They hid the dependency graph? No. Okay, let's see what this says. If I just go here to this. Okay. Blueprint, documentation, paper. view on GitHub. They did not build the dependency graph. Shame on them. Anyhow, there should be a lot of stuff. So just writing the blueprint, I think, is going to take like a year. That's why I was cutting down some of your projects, because you were heading in this direction. Okay, should be a reasonably sized project. Any questions? We can see what happened to my update. Well, something got updated. I can still do it later. But anyhow, the best way to proceed is to just do things. When you get stuck, ask on Discord. There's a good chance somebody knows the answer. And there's a good chance you will get the answer before I actually see the Discord question. So use that. You can also use the Zulip, Lean Zulip server, where people are also quite friendly, and you can ask there if you get to something weird. Try searching before you ask, because it's huge and it's likely that it's already been answered. And another resource is the Proof Assistance Stack Exchange, where people answer these questions. Okay, I think I'm done for today, unless, like, are there questions? I'm sorry I couldn't show you the little what's going on. What if I switch to a reasonable network? My kids think it's really super funny that that's the name of my iPhone. So that's why I keep it. Okay. So there's something going on. Oh. Ooh. Is it possible that they're firewalling YouTube on the academic network of this department?
It works on my machine.
But what network? Because I was, yeah, well, I was in FMF. No, but it wouldn't be Željko anymore, something else. No, still the same problem.
Yeah.
I'm just not worthy. I don't know. Anyhow,
You could just scroll through that.
maybe we can maybe we can give up.
You can borrow my computer.
But you see, it's something fancy. Look, see, it's cool. And now imagine that somebody formalized this in Lean. Of course, they didn't formalize these pictures in Lean. They used a much more general theorem that allowed them to conclude that this thing must be possible. Okay, I'll call it a day for today, and we can actually spend some time maybe discussing the projects and so on. Next week, I would like to do the inductive types. Is anybody going to hit inductive types? You're not. Luna will hit inductive types for the formal systems. I think Matej might hit inductive types when he tries to define what a logic is. I think that's about it, right? Yeah. Okay. Anyhow, it's good to know about inductive types. It's general knowledge. Okay. I think we're done for today.